All right, section 4.5, linear equations in 3 dimensions. So the big two ideas here is we're going to be graphing points in 3 dimension, ordered triples, and then we're actually going to be graphing some linear equations on the coordinate space, I guess, not a coordinate plane. So it says so far we've graphed points and lines in 2 dimensions, typically on the xy coordinate plane. Today we're going to graph points and linear equations in 3-dimensional coordinate system called coordinate space. Each point in coordinate space can be represented by an ordered triple in the form of x, y, and then now we're going to add z to the end. This will be similar to our coordinate grid, but with the addition of the z-axis. So I already drew, well, I didn't draw, but I had the computer draw the grids on here in 3 dimensions. And typically, this is the way that it goes. I mean, you can rotate this around and set these up a little bit differently. But if you'll notice, what you could visualize is, you could visualize the y and the z as being like on that piece of paper. And then the x-axis actually coming out to you, right? So as the x-axis comes out this way, you know, out here, that's going to be the positive direction. So this is going to be 1, 2, 3, and 4. And then the y, positive direction, will be 1, 2, 3, and 4. And then the z direction going up is positive. 1, 2, 3, and 4. Now you could rotate this around and look at it from different views, but this is pretty much the standard way that you'll see it done throughout the rest of your math classes. So right and up are still positive, but coming at you is positive, where going away from you is negative on the x-axis. Now, these can be a little bit tricky, so I'm going to try to give you a way to graph these. So let's look at the first one. 2, 3, 5. So remember, x is the 2, y is the 3, and z is the 5. So when I go to the 2, I basically start from the origin 0, 0, and I'm going to come out right here to the 2 direction. And then we're going to go in the positive 3 direction, okay, which means I'm going to start heading this way. Now, I don't want to go all the way over to 3 because you kind of have to draw parallel lines. So if I know I'm going to be going over here to 3, I'm going to try to draw a line parallel with the x-axis over here so that I can kind of get this spot that crosses, and don't pay attention to that mark on the z-axis. What I want to do is I want to go parallel from this point 2 over, and I'm kind of nitpicking here, but so now I'm at a spot that's 2 on the x-axis, it's 3 on the y-axis. Well, now I need to go up to a height of 5. You can almost make these things look kind of like a little box. So if I go all the way up here to 5 on the z-axis, to kind of complete this box, I need to go up from here. And I want to try to maintain, you know, keeping lines parallel with each other. And if I go straight over to here, that'll get me that corner. And what I'm trying to figure out is I'm trying to figure out roughly about right there. It's pretty doggone close. So really the point that you end up graphing is always ends up being one of these vertices on the corner of this box. So it should be that, hopefully if I did this right, I went 2 in the positive x direction. I then went over 3 in the y direction. And you know that green line should match up lengthwise with that green line, roughly. I mean, we're just kind of sketching it. But then, you know, notice I don't go all the way up and put a dot beside 5 because it's 3 dimensions here. So going up, and I stop right there. And hopefully that line is pretty close to the length of this line. But you'll notice that my height is not even with the 5. You know, it's kind of down a little bit. So these are a little tough. They take some practice. So let's see if we can do it again on the next one. I need to go 4 in the x. I need to go 2 in the y. and 3 in the z. So let's come 4 to the x. So right there, there's 4. And now I need to go positive 2 in the y. Well, if I go over to 2 in the y, that's this direction. And if I keep these parallel until I meet up with this one, it's going to put me, and you're always kind of in no man's land. I can just kind of put me in this random spot down here, which looks pretty good. And now I got to go up 3. All right. So what I want to do is I always want to kind of start on the axes. So I want to go up 3. So to kind of keep this box going right, I need to try to stay parallel until I come over here, maybe a little bit further. And this goes straight over to right here. And then I'm going to come over, need to go over the same length roughly to match up here. So I kind of complete my box, and I was a little bit off there, but it looks like this red dot right in this area is going to be, 4 out at me, 3 or 2 over to the right, and 3 high. And visually, hopefully if you do this thing right, this height should be the same as that height. It should be roughly 3 up there. So there's my spot out in space at 4, 2, and 3. All right, I think now we're going to get into maybe a few negative ones. Let's see what's going on. Number 3, I got 3, negative 4, 5. So again, I'm going to have to draw a 5 up there because we didn't have one. So let me draw 5 up top. And for this one, I'm going to need to go in the negative direction. So this is my x, this is my y, this is my z. So 3 positives, that's going to come at me. So I go on the x-axis to 3 positive. So there's that spot. Now I got to go 4 in the negative y. So 4 in the negative y from the origin is this way. So there's at negative 4. This was at 3, positive 3. And now we got to go 5 up. So 5 up is going to put me, right up here. So let's see if we can make a box out of this. I'm going to do my best to keep this thing. That doesn't look very good. And it doesn't have to be perfect, but I'd like to get it as nice looking as I can. Come out, come over, and then I need to go straight up until I get to about where I think it looks like it's. Now, if I had a ruler, I could actually make this perfect. Some of you guys might be into art. You kind of do perspective drawing. So this is kind of a nice way, and I'm off a little bit there, but it's good enough. So it looks like this point right out in here would be, 3 coming at me, negative 4 to the left, and a height of 5. And that would represent where this point lives. So notice it's always a corner on one of these boxes. In the homework, you do get some that are 0, which those are easier because they're going to be just flat on one of the walls, and it won't actually really be 3-dimensional. So those are kind of nice. They're a little bit easier. So I thought I'd do the harder ones in the notes. All right, let's try this last one here. So I got to go 2 on the x, which is away from me, 4 on the y, which is to the right, and then 4 down, which is the z. So here we go. So x coming at me is positive, so going away from me is negative. So I'm going to go back to negative 2 back there. And then I'm going to go over 4. So that kind of makes the bottom, of my box. So right here is the 2 back and the 4 over. Now we got to go down negative 4. So I got to go down 1, 2, 3, 4. And then I want to kind of complete this box. And here's where you got to kind of freestyle it a little bit. You want to try to be parallel as best you can. Doesn't have to be perfect. And there we go. So that's backwards. So we are 2 away from us. We are 4 to the right. And then we are 4 down. So that would be that point in coordinate space. -2, 4, -4. All right. So those are graphing the dots. Now we're going to get into actually trying to graph some linear equations. And whenever you graph these things in 3 dimensions, all right, in 2 dimensions we're graphing lines. Whenever you have three variables here, x, y, and z, these are going to end up being, we're going to graph planes. And recall from geometry, a plane is like a flat surface. Technically, it goes forever in all directions, but it's going to be like a sheet of paper or a sheet of glass is what this is going to end up being. Now, these can get very, very difficult, so we try to keep them simple. And basically, we're going to graph these by finding the x, the y, and the z intercepts. So I'm going to really hand select nice equations that we can do finding the intercepts. So if I want to find the x-intercept, what I'm going to do is I need to let the other 2 letters be, I need to let y and z both be 0. And I'm going to find the x-intercept. So when I put zeros in here, it basically wipes out this one, it wipes out this one, and I have to solve the equation 3x = 12. So it looks like the x-intercept is 4. So I go on the x-axis and I come out here and I put a line or a dot right there at 4. So there's the x-intercept. Well, now I want to find the y-intercept. Same game to find the y-intercept. You let everybody except for y be 0. So you plug 0 in here, 0 in here. We're going to find y. So I come back over to my equation. 0 is going to wipe those 2 out. And y is going to be equal to 3. So I go on the y-axis to +3. And there is going to be the intercept. So these are spots where my plane is going to cross through at these points. So imagine a sheet of glass cutting through space at those points. Now my last one is I have to find the z-intercept. So again, when you want to find the z-intercept, you let the other letters equal 0. So you're 0, you're 0. Got to figure out what z is, so I come back to my equation. And you can see that, unless you want to get into fractions, it's nice when you have all of these numbers go into the number over there by himself equally. It makes it finding easy. But 0 is going to wipe those out. And we're going to get z = 6, which I'm going to have to, it's like I chose a problem that I have to extend my line a little bit here. So z is just going to go up a little further, and we'll try to space it out. It looks like that would be 5, and it looks like maybe that would be 6. So I'll put a dot up there. Now, technically, you would kind of draw this plane that goes through those points, but that can be kind of difficult. So a lot of times I'll see in classes, they'll basically draw this kind of triangle to show, all right, to show that that's the plane on there, and I could shade it if I wanted to, and kind of do like that. But imagine it's not really a triangle. It's really a flat surface that slices and goes through. It cuts through those 3 points, but goes forever. The problem is if I try to draw it, like as a plane, I have to stop it somewhere, and it just kind of ends up like engulfing the whole engulfing the whole thing. And it kind of looks goofy, like when you just have a big rectangle drawn on there. So it kind of looks better when the triangle's leaning, but just realize that it's really, we're not graphing a triangle. We're really graphing a three-dimensional plane, or two-dimensional plane with no thickness that actually goes through all three of those points. I think at the end of this lesson, I'm going to try to find a grapher. I think GeoGebra has a 3D grapher where we could put this in and then we can kind of visualize it a little bit. So I'll try that here when we're done. Let's do another one just so we kind of got the hang of it. So here's another one, and I'm going to move a little bit quicker through this example. So we need to find the x-intercept, we need to find the y-intercept, we need to find the z-intercept, and the x-intercept, you let these two be 0, so x equals 4, slap it on there. Maybe I'll do this one in blue. Then for the y-intercept, negative 4y equals 4. If I divide both sides, it looks like y equals negative 1. So on the y-axis, I'm going to go over here to negative 1. And then for the z-intercept, well, for the z-intercept, it looks like z equals positive 2. So the z-intercept is positive 2, which would be right there. So now my triangle, you know, it kind of cuts through here and then goes up. Oh, and this is a really hard one to draw. You really can't see it very well because it's kind of looking at you. But in 3 dimensions, that's a really weird looking one. So maybe I'll try to graph this one on GeoGebra 3D. So let's see if we can do this. I'm going to pause the video and try to get that set up. All right, so here's the GeoGebra 3D calculator, and I'm going to try to input that last example on here and see what it looks like. So I think we had x, and I'm not sure, looking at, like, I'm pretty sure this is the z-axis. I'm not sure if they're going to, because I noticed like this is positive and this is negative coming at me. So they might be calling this x and this y and this z. I guess we'll kind of have to see what it looks like. But let's just punch it in. So we got x. Yeah, so that looks like this is x and this is their y. So x minus 4y. So that kind of shows that sheet of glass coming down. Plus 2z equals 4. All right, so there it goes. And, you know, you can kind of zoom, you can scroll your mouse and zoom in or zoom out. And I do see that it's cutting through 4. And then it looks like it's cutting through, and you can kind of grab this and you can kind of rotate it around. So it looks like it's going through 4 there. It's going through negative 1 there. So maybe I'll try to, oh, this is really weird. I'm going to try to orient it kind of similar to how we had it. So here's almost how ours looked. So the green line was our x, our red was our y. So we came 4 at ourselves, 1 this way, then we had to cut through 2. And we really couldn't see the 3 dimensions very well, the way our graph was placed. But if we were to rotate it, what I'm doing is I'm just kind of grabbing this with my mouse and slowly, but we can kind of see how that slice looks by rotating it around. This is really cool, this 3D grapher. So if you just punch in GeoGebra 3D, you can really see like, oh, it cuts through 2. Like right here, it's kind of hard to see where it's cutting through on the z-axis. Like it almost looks like it's going through 4 or 3. But when you really get it set up just right on the rotation, you can perfectly see that it's cutting through a height of 2. And you can actually flip this thing like upside down and look at it from the bottom. It's pretty cool. But that's a nice little way to graph some things and see if yours matches up. All right, hopefully this helps you out and you are able to do the practice. Be sure to ask me in class if you have any questions. See you.